Hello everyone, myself Bandgar S.S., working as Assistant Professor at Department of Physics at HM College, Nasa. Today we have to going to discuss S.Y.B.Sc paper 2nd semester 3 Instrumentation. In this video we have to going to discuss first chapter Fundamental of Measurement, and we have to cover up the subtopic of static characteristics of measurement system. First topic is the fundamental of measurement. So, starting with a measurement system characteristics. The performance and ability of characteristics of measurement system is mainly divided into two categories. So, the measurement system characteristics or their performance or their ability is divided into two categories. First one is the static characteristics and second one is the dynamic characteristics. So starting with a static characteristics, it is the set of criteria defined for the instrument which are used to measure quantity which are slowly varying with time or mostly constant. That is, do not vary with time is called as static. So static characteristics is the constant. It is nothing changes with a time. It is the very slowly vary. It is near about constant, stable. So that's why that is the called as the static characteristics. So we have to see the some static characteristics like as a accuracy, precision, sensitivity, linearity, repeatability, reproducibility, drift or error, hysteresis, dead zone or threshold, and resolution. So these 10 static characteristics we have to see in a detail. So these are the static characteristics we have to see in detail how to it is related with a measurement system or how it is the useful to our any application or any purpose of the measurement system. So starting with a accuracy. Accuracy, it is nothing but a get the good desired output. It is the without error free output, or it is near about we have to get the more precise output, very desired output, that is the known as the accuracy. So accuracy is closeness of the measurement to a specific standard value, true value or actual value. It is nearness of the true value, standard value and actual value or specific value, that is the known as the accuracy. The accuracy is also measure of the degree of closeness of measured or calculated value to its actual value. Whatever your output is calculated or measured by a measurement system is near about your actual value, true value or standard value. That is the known as the accuracy. So it is the measured in percent of deviation from the standard, true value or actual value. So actually it is measure the deviation between the your true measured value and true value or actual value. Accuracy is closely related to precision and depends on the limitation of the measuring instrument and inadequacy in the measurement process. So it is closely related with precision, but that depends on the limitation of the measuring instrument and inadequacy in the measuring process. So accuracy means your measured value you cannot get the like as a true value, actual value. So there are errors. So these are the different errors. So we have to measure the errors, then you will get the how much your output value is accurate. Percentage of accuracy of true value is equal to error upon true value into 100. So error means whatever measured value and whatever is true value, that is the difference, that is the known as the error upon true value into 100. So same as percentage of full scale deflection. Percentage of full scale deflection accuracy is equal to error upon full scale deflection into 100. Means measured value minus true value, that is the error. So percentage of true value is more accurate than percentage of full scale deflection. So it is the single value that is the more accurate than full scale deflection. Consider one example. A current meter of full scale deflection is 1 ampere and error is plus minus 1%. Then percentage of true value current meter read from 99 to 101. 1% is error. But when we take the percentage of full scale deflection, then current meter read 90 to 110 meters. So there is the plus minus 10% error is occurred in full scale deflection. So that's why we have to use percentage of true value is more accurate than percentage of full scale deflection. Second one is the precision. It is the ability of an instrument to reproduce a set of readings within a given accuracy. So it is the very precise and accuracy. It is closely related with your standard value, true value. So it is also closely related to the accuracy. It is the repeatability of the result decides the precision of instrument. The repeatability of result is high, then precision of the instrument is the high. If the repeatability of result is high, then precision of instrument. So repeatability of the instrument or output generation of the instrument or measurement system is high, then that measurement device, it is the very precise or their precision ability is good. It is also some error because of it is not equal to the actual value or true value. So that's why there is some also error. That is the precision of error of instrument is said to be equal to plus minus 1% when accuracy of repeated out of transducer or instruments lies within plus minus 1%. So precision of error you cannot the exceeds than plus minus 1%, or it is the repeatedly generates the outputs, that's why it gives the very precise output. Second one is the sensitivity. The sensitivity denotes the smallest change in the measured variable to which instrument responds. So sensitivity means how much given to the input and how much change the output. So that depends the how that measuring system is the sensitive. How much smallest change is sensed by the measuring system and generates the output, that is the denoted by the sensitivity of the measurement system. It is also defined as it is the ratio of the change in the output of an instrument to the change in the input value of the quantity to be measured. So whatever input quantity you have to change, it is changes with the output. That is the ratio is known as the sensitivity. So sensitivity is the formula of changing output upon changing inputs. So there is some mistake changing input. So at the denominator term is the changing input. If the response curve linear, then sensitivity is good. If input changes and that is the directly proportional related with output changes, but means there is the linear relation. So their input output relation or input output characteristics of the measurement system, that is the linear. So that response curve is linear. Then you have to say the sensitivity of the measurement system is good. Example, LVDT, variable inductance, variable capacitance, transducer. And second one, if the input output relation of the measurement system is the non-linear, so their response curve is non-linear and sensitivity is the poor. So sensitivity is the very poor in a non-linear relation in a input output. Example, thermistor, photodiode and strain gauges. These are the example of the non-linear sensitivity of the device. So this diagram or this IV character shows the linear sensitivity and non-linear sensitivity. So first one is the linear sensitivity, static sensitivity of linear. The x-axis, that is the input, y-axis is the output, and you get the straight line. So there is the linear relation between input output. Then sensitivity is the good. Second, of input and output of the measurement system, there is the x-axis input, y-axis output, but their transfer curve is a non-linear. So that sensitivity of that measurement system is a non-linear. So this is the non-linear sensitivity of the device. So these two IV characteristics, the relation of input and output of the measurement system, when it is the directly proportional, that is the linear. When it is the not directly proportional, that is the non-linear. Next characteristics of the measurement system is the linearity. Linearity is a measure of quality of an instrument. So when it is the linear relation in input and output, then you can set the very good instrument for a measurement. So it is the closeness on output value from the ideally fitted transfer curve of an instrument as a known as the linearity. Whatever ideally fitted transfer curve of any instrument, and you will get the output like that ideally fitted transfer curve, then you can set the linearity of the device. The linearity is defined as the ability to reproduce the input characteristics symmetrically and linearly. So linearity gives the output in terms of symmetrically and linearly. So it gives the proper linear characteristics of the measurement system. So linearity provides a linear relation between output and input of the measurement. So it gives the relation between the input and output terms. Next one, linearity is never completely achieved, so that the maximum deviation from ideal curve often specified by following range. So any measurement system, you cannot get the 100% desired output. So there is some errors, some noise and some input output variations. So that's why we cannot get the completely achieved the linearity. Not proper generation of linearity, we have the three types. First one is the independence of the input. So it is the simply output of measuring system is independent of input value. So here output is not generated with linearly with a input value. So therefore graph of non-linear type, and the curve deflects the value in terms of positive, negative, percentage of full scale deflection. So we have to given the IV characteristics of the input output. So that is the dependence of the input, that is the linear relation, but we have to see the ideally fitted linear line, fitted curve, and you have to generate the second like as a sine waveform. So see the waveform, it is the fitted with a closely linear with a ideally fitted curve. So that is the independence of the input. Input is the constant, but output are the changes. So that's why that is the called independence of the input. Second one is the dependence of the input. In this case, variation in the output value of measuring instrument is the function of variation of the input. The value that therefore the graph non-linear type, the curve deflects the value in terms of plus minus positive negative percentage change of the slope. So you can increase the input value, so output value are also changed. So there is dependence of the input. When input are changes, output are changes. The slope of the output curve here are changes. So we have to see in the ideally fitted curve is straight line and their output is the like as a sine waveform. See, first time their deflection is the minimum, but when we increase the input, then output are also increases. So their deflection, positive negative deflection is the more. So that's why that is the non-linear type curve, and that is the depend on the input. So that's why output is the changes. Next one is the combined dependent and independent of the input. It happens when there is variation in output proportional to the input certain region input output characteristics and independent of input for remaining part of the input output characteristics, independent variation in the output at the higher range and independent variation at the lower range. So when it is the independent on input, then there is the minimum deviation, and when it is the dependent input, then it is the maximum deviation at the curve. You have to see in the diagram IV characteristics input output relation. The when starting with a independent variation, so there is the lower or minimum deviation at the curve, but when we use the independent variation, that time input output deviation, input variation max, and there is output deviation is the maximum. So that is the combined dependent and independent of the input. That is the third type of the linearity. So that is the three types: independent input, dependent of the input, and third one is the combined dependent and independent of the input. Next, static characteristics of the measurement system is repeatability. It is a repeatability of the instrument is defined as the ability of instrument to reproduce a group of measurement of the measured quantity under the same operating condition. So it is the ability of instrument to reproduce a group of measurement of the measured quantity. So there is no change any conditions, you get the same readings or group of measurements of the same quantity under the same conditions, then you can say the repeatability of the instrument. It gives the performance of the system or units, which gives the that ability or performance of the system or units. This required to product quality and safety of the instrument. So that require because of it gives the or desired the product quality and safety of the instrument. Next one is the reproducibility. Reproducibility of the instrument is defined as probability that it will perform at its assigned function for a specific period of time when hysteresis are included. So reproducibility, it is the performs their assigned function in specific period of time, that is known as the reproducibility of the instrument or measuring system. It is also defined as it is the degree of closeness with which a given value may be repeatedly measured. So repeatedly measure the value. It is the degree of closeness of true value that is known as the reproducibility. The reproducibility of sensors depend on the user, manufacturing methods, and individual parts are used for that operation. So these are the three terms are used for to the reproducibility of the instrument of the measuring system. Next static characteristic is the drift or error. So drift is the variation in the output of the instrument from the desired value from a given input due to change in sensitivity and interfacing inputs like a temperature, components, inabilities, instabilities, etc. to minimize the error due to a drift. So you have to calculate total error, zero drift plus sensitivity drift. So drift, it is nothing but some technical error in an instrument. If you have to require a 5-volt output voltage, but you will get the 4.9. So 0.1 is the error or 0.1 is the drift of that measuring system. So we have to, because of that generates, because the various parameters affect like as a instrument temperature, component instability, and any other interfacing inputs. So these are the affects the your output. So you will, that's why you will not get the desired output. So you will say the drift or error of the measurement system. So it will be the minimize the error due to a drift. You can whatever desired output we have to require, you will to you want to minimize by using a drift. So total error of the measurement system you can calculate by the zero drift, that is the initial position, that is called as a zero drift, and second one is the sensitivity drift. So sensitivity means how to your measurement system sense and gives the desired output related with the input and output. So that is the known as the sensitivity. So total error is calculated by a zero drift. So you have to see a diagram what is the zero drift and sensitivity drift. So zero drift, it is the some initial time or some initial parameters is added to your output, that is the known as the zero drift. And sensitivity drift, some parameters is affect temperature like as a component instability, interfering, other noise and something error. So that is the known as the sensitivity drift. So we have to see in the ideally fitted transfer curve, that is the calibration curve, and your output, that is the upper straight line C. So you have to require from zero drift initial condition like that calibration curve, but that some bending because of the sensitivity drift. So there is some parameters is affected. So actually operating curve is upper straight line or dotted line is the you have to required or generated output curve, but that not generated because the sensitivity drift, and you will get the upper straight line, that is the actual operating curve, that is the your get the output of the measurement system. Next characteristics is the hysteresis. Hysteresis is defined as the magnitude of error caused in the output for a given value of input when this value is approached from opposite direction, that is ascending and descending order. Hysteresis is error measurement method. There is small change in measured value when the input varied in increasing and then decreasing manner. So hysteresis, it is nothing but the small error measurement technique. When variation of in input, there is the changing the output like as a increasing and decreasing manner. So that is known as the hysteresis. So we have to see in the how to hysteresis error generated. So input given input in x-axis, output in y-axis. So you have to see increasing and decreasing manner. How to upper arrow, it shows the increasing manner of output, and downward arrow, it shows the decreasing manner of the output. So that it generates the hysteresis. So that is the called as the error. So that is the hysteresis error. Next one is the dead zone or threshold. So when we given to the input of the system but our measurement system doesn't respond, or measurement system or instrument doesn't give output, so that zone or that time or period or operating time is known as the threshold time, dead zone of the measurement system. It is the maximum value of the input parameter for which the instrument does not respond. It is the change of different input minimum values over which there is no change in output value. Example, hysteresis caused by the mechanical instrument due to a Coulomb switch. So that diagram shows the minimum dead zone or minimum threshold is required for to the any instrument. So initial time for to activate the instrument, that is known as the dead zone. I mean, input are given but output doesn't respond, that is known as the dead zone of a instrument or threshold of the instrument. Next parameter of the measurement system is the resolution. Resolution is defined as the input change which produce measurable change in output. So smallest change in input will get the change in a measurable output. That is known as the resolution. When input of the instrument is increased slowly from some arbitrary value, output does not change until certain definite increment is achieved. This increment is known as resolution. The resolution is the ability of measuring system, including observer, to discriminate between nearly equal values. Thank you.